This paper was on something known as Brownian motion. So Brownian motion is actually something that was discovered in 1827 by Robert Brown. And he saw when he immersed flower pollen, into water, he saw that even when it was completely stationary, like complete at thermal equilibrium in a totally isolated environment, nothing was affecting it, the individual pollens would be vibrating, would be moving in the water. And again, this might be like, well, what's the big deal, right? Like, but again, as a scientist, you might be like, well, why are these things moving? And it turns out that was the very first experimental evidence of an atom, of atoms, basically, showing that there is something smaller than just water. That in the water, there's something in there that's causing these pollen to move. Anyways, many years later, obviously 1905, this is when Albert Einstein releases this paper on Brownian motion. He basically describes, now remember, Brownian motion is also, I should have mentioned this, is also kind of characterized as random motion, because there are all kinds of, there are just atoms in this system. What are atoms doing? They're just moving, like individual atoms are just moving in all sorts of directions. There's no uniformity to them. When you say, like, atoms usually are not all going in the same direction. If you find, for example, an equilibrium or some sort of, if you have like a magnetic pull, sure, you can maybe face them in a direction. But on average, or individually speaking, all the atoms are just everywhere, random motion. Einstein comes in and he basically devises an equation for this motion. Brownian motion. And it's surprising to everyone, more so because of what this proves. This is the first ever mathematical proof of an atom. Basically saying that atoms in the water is what is causing these pollens to move. So microscopic movements from the pollen, for example, like there might be a little more concentration of atoms moving in one direction than the other. So the pollen is vibrating. There might be a little in the other direction, and their pollen is vibrating. So basically, it's just because of this random motion that then Einstein described using this theory that he then called Brownian motion, was again explained as the very first proof of an atom. Again, further just breaking science. Just completely breaking.
Yeah, that's crazy. Especially because,
yeah.
One, he kind of discovered that. Well, he didn't discover it, but he like analyzed the situation, came to a conclusion.
Mm-hmm.
And then later in his own lifetime, he got to see like all of these advancements in our understanding of the structure of the atom. And then, I don't know the exact timeline, but by the end of his life until today, like has our understanding of like the model of the atom changed that much? Do you know?
I don't think so. Because when we're talking about the classical, just the Bohr-Rutherford model, like we're still taught that in school, and that is what we learned for a long time, right? Like the quantum model is taught, in years of university. So I think it's still applicable just for like energy levels and stuff. Remember, like, quantum model is just like, it just overcomplicates a lot of things, but just to understand the discrete nature of energy levels and everything, just drawing circles around a nucleus works. So